Okay, welcome to SIG Auth on August 23rd. You should be seeing the agenda projected. This is David Eads. I'm picking this up for Jordan. It's been a while, but I think I remember how to do it. So first, announcements on the agenda. The Container Identity Working Group, it's Friday at 11 a.m. It's in that window where we're trying to hit East Coast, West Coast, and maybe Europe. But if you're interested, the last one was interesting. I'm sure that this one will be too. Code freeze is on September 1st. So I've been seeing several polls come in. I think that our features are pretty well set at this point. But if you have something that needs to go in for freeze, that's not a bug fix. Make sure that you and your reviewers know. And I've seen myself and Eric and Jordan have all been pretty responsive on approving and reviewing various polls. Is Evan here?
Yeah.
Hey. Oh, and now we get to transfer the share screen to you for the demo on SPIFFE.
I hope this works after all the difficulties that I've been witnessing. Let's see here if I can show you guys something.
Evan, could you briefly introduce yourself? I don't recognize you offhand from other features.
Sure, yeah. I'm kind of new. I've been kind of lurking around SIG Auth and also attended the first container identity meeting the other day. I've joined recently a company called Cytail, which is working on SPIFFE. And you know, the work that's going on in SIG Auth and the work that's going on in container identity is very similar to the stuff that we're trying to solve in SPIFFE. So you know, I've just kind of been hanging out, tracking your progress, and you know, here today to kind of give you guys a brief on the stuff we've been working on, and maybe explore, you know, how those things align, and if there's some reusability.
Okay, thank you.
So can you guys see my screen here?
Yes.
Awesome. Okay, yeah, so like I said, my name is Evan Gilman, and I've been working on this SPIFFE standard and also this software project that is now called SPIRE. Just kind of, like I said, there's a lot of overlapping work that's going on in these two areas, and so I kind of wanted to take some time to present to you guys the work that we've been doing, and see if there's opportunity for reuse or see what makes sense for you guys, and also talk a little bit about the integration we would like to integrate with Kubernetes, and we have some ideas on how to do that, and so see what get some input from you guys that would be valuable as well. So today, you know, the first thing that we'll talk about is kind of like what exactly is SPIFFE, what are the goals, and what is the definition of it. We'll talk about SPIRE, the software project, a similar thing. What are the goals? What does it look like architecturally from a high level? What are we trying to accomplish? What SPIRE looks like, what we think SPIRE will look like with the Kubernetes integration, and then finally, you know, what a world, a SPIFFE supported world would look like in Kubernetes. And these are two different kinds of things, which are layered on top of each other. So I hope to kind of talk a little bit about that today. So the first question is just kind of what is SPIFFE? SPIFFE is actually just kind of a set of standards. Right now it is two standards, and there's one that's currently under development. The goal of these standards is kind of to codify a way to communicate service identity, and do it in a way that everyone can understand, no matter where you're running or what stack you're on, or those kinds of things. And we look at this as kind of an enabler of federation and heterogeneity, in that, you know, if we can land on a standardized way to encode identity and communicate identity and validate that identity, then we can begin to do really strongly authenticated communication across organizational boundaries, across data centers, across different clusters, things like that. So we think that standardization is kind of the right way to go in solving this problem. And the problem is only getting larger, you know, with multi-cloud and all this kind of stuff. So what exactly does this set of standards consist of? The first one is a standard around kind of an identifier, an identity namespace, if you will. And we have this defined as a URI with a SPIFFE scheme to it. We don't have a lot of like rules around how this is formed. It's meant to be fairly flexible, and a lot of it is opaque to the SPIFFE standard itself. SPIFFE standard is more around like the set of standards is more around like how to transmit and validate these identities. But this identifier has some loose rules to it, and we call this thing a SPIFFE ID, and it serves to kind of identify the service which owns the identifier. We have another standard which defines what we call verifiable document, or SPIFFE verifiable document, which is SVID for short. A SPIFFE SVID can be any number of things. There are some constraints placed and requirements placed upon what qualifies as an SVID. And then there are further standards to say, okay, this is how you encode an SVID of type foo or bar. Currently, the only supported SVID type is X509, and it uses pretty standard X509 semantics with a little bit of extra validation layered on top of it. And finally, the third standard that we're looking at is an API endpoint, and this API endpoint serves to retrieve these certificates, these standardized identity certificates from a workload. So a workload, when it spins up, will hit this standardized endpoint, and some validation will occur. The type of validation that occurs is up to the implementer. But we thought that it would be a valuable thing to standardize on kind of the interface of this endpoint so that SPIFFE-enabled workloads could be portable. The implementation of how that API is actually realized is kind of out of scope for this set of standards.
You use the word certificate. Did you mean certificate and key pair, or is this just where I can get public certificates for some kind of validation?
This is both. This endpoint will give you a certificate and a key pair for use in identifying yourself, and will also provide you like CA bundles, which you should trust externally, and that's how the federation bits function.
Okay, thank you.
Does that make sense?
Yes.
Cool. Yeah, so the workload, this is what we call the workload API. The workload API is still under a little bit of flux, but we should be kind of settling on what that interface looks like shortly. We've been working with the gRPC team. They have had some input on what they would like to see here, and are planning to do native integration there. So we've had some back and forth, and that standard is currently in flight, but we expect it to be landing soon. So this is kind of the set of standards which is SPIFFE, and the goal of these things, as I mentioned earlier, is really interoperability of service identity. So through these three distinct standards, we hope to set forth a way that individual projects can implement themselves or consume through our software project, which I'll speak about next. The goal being like, hey, my Kubernetes cluster over here can talk to my Mesos cluster on this different provider, or perhaps, to different companies even. And so through this API endpoint, we deliver those creds and the bundles, which should be trusted for that mechanism. So the next thing we have is this project called SPIRE, which stands for, I think it stands for like SPIFFE Runtime Environment. And this is essentially an open source project which looks to implement kind of the SPIFFE standards. Of course, there's a lot more that has to happen than just implementing certificates and endpoints. So this project is much larger in scope than the set of standards itself. And really what it aims to do is it aims to mint and issue these certificates automatically in a secure way. And the way that we do that is it's very, very flexible and very pluggable. So we have different plugins for different compute providers. There's kind of two levels here where we do an attestation for the compute layer, or the platform or node layer. And then we do another attestation for the workload itself, the thing which is calling the workload API. So because it's pluggable, it can work across a variety of providers and variety of runtimes. And we also enable folks to kind of write their own plugins if they have some in-house attestation mechanism or business logic that they would like to exercise when nodes come up or when workloads come up in order to validate that they're supposed to be receiving these certificates. That is possible. So I'd like to talk just a little bit like kind of architecturally what SPIRE looks like. Hold on, I think that I'm being chatted here. Yes, SPIFFE.io, and also there's a GitHub, SPIFFE, which will be on the end slide, but I dropped it into the chat.
Is SPIRE on that GitHub?
SPIRE is still like under very heavy development by the Untitled team and a few of the folks that have been engaged in SPIFFE for a long time. We're planning on opening it up in the near future. The plans for SPIRE is for it to be a fully open, community-owned project. It's not going to be Docker style or Nginx style or anything like that. But it is still kind of, not all the code is not all there yet. So we're quickly churning towards kind of like a fast and rough release that we can kind of put in people's hands, but it's still pretty early. So the answer there is no, SPIRE is not public yet. This repo contains all of the standards docs that we've minted to date. It also contains information about the community, how to join the community, and things like that.
Awesome, thanks.
So let's take a quick look here at the SPIRE architecture, at least what we have on paper now, and then kind of what we're heads down busy implementing at the moment. So this is kind of the 30,000-foot view. Where there are two major components to a SPIRE deployment. There's a node agent which runs on every host, and there's a control plane which handles the authorization and the minting of the actual certificates. So these red boxes that you see here, those boxes represent like API endpoints, and the bright green boxes that you see, those boxes represent like plugin interfaces. And some plugin interfaces can contain more than one plugin. So you'll see on the node agent here on the left. For Workload Attester, we have both Kubernetes and Linux plugin running simultaneously. And so the basic flow here is what happens is that when a node comes up, the node agent first fires and then is seeded with some information how to contact the control plane. And so it contacts the control plane using just regular TLS. And it goes through the process called node attestation, which is this pluggable piece. And in this diagram here, we have an AWS-based node attestation, which essentially exposes, an instance identity document that the control plane then takes and then calls various Amazon APIs to validate the authenticity of that document and validate, kind of the integrity of the machine which has presented it. And once this node attestation passes, node attestation can have multiple plugins as well, depending on what platform you're running on. Once this node attestation passes, a node certificate is minted and issued to the node agent, which the node agent then uses to request further certificates on behalf of the workloads calling the workload API. So of course, when this happens, when a workload hits the workload API, we need to understand, number one, what this workload is, and number two, what SPIFFE ID should we be issuing it. But we don't expect the workload to know this information beforehand. So we have the registration API. This is an example of, kind of what the registration API interface looks like, kind of very rough pseudo interface here. We issue a set of selectors, and the set of selectors says, describes essentially the workload. And we give a parent ID, and this parent ID is essentially the SPIFFE ID of the node which is authorized to run and issue a workload, a certificate to the workload described here. And then the SPIFFE ID is the SPIFFE ID to actually issue this workload. And you can see that the TTL is adjustable, so we can give short-lived cert. And federated bundles is the portion where we can give CA bundles for external chains that we want to trust as well. And on the right-hand side, I just kind of gave some mock Kubernetes specific selectors for a workload. I'm not, I haven't been running Kubernetes for very long, so please do excuse me if some of these things don't quite make sense. But then these selectors can be combined, as you can see. So for the continue. Sorry. Okay.
Oh, I have just a quick question. Back, if you look at the design, so I know that SPIFFE is used in Istio as its sort of identity format. can you comment on sort of how the SPIRE, architecture from 100 feet is maybe different than Istio or similar?
Oh yeah, absolutely. So right now, I've seen a little bit of the SPIFFE code within Istio. Istio is not so. This is kind of the distinction between these two works. Istio is compliant with the SPIFFE specifications, the set of standards that we've set forth. So SPIFFE has its own CA mechanisms and signing mechanisms, Istio has its own CA and signing mechanisms through which they issue SPIFFE compatible certificates. I believe that they're also working on implementing the workload API as well. I know the gRPC team is, and I think that the Istio team is also interested in this. But the Istio, as of today, is not using kind of any of the SPIRE workflow or logic. This is for folks who don't have any of the signing semantics in place today.
Awesome, thanks.
I think it's more accurate to say that Istio supports SVID as a form of identity, rather than say Istio uses SPIFFE.
Sure. So that's kind of what the line I'm trying to draw here is, that there is a definite difference between SPIFFE, this set of standards, and this software project. So I wouldn't say use SPIFFE, but I might say SPIFFE compliant, if that makes sense to you.
That sounds right.
Yeah. So Mike has kind of been following our progress on SPIFFE for a while, and there's a little bit of confusion because we previously did not have a name for SPIRE, the software project, and the name SPIFFE had been used interchangeably in the past. So we're trying to kind of clarify that these are definitely two different things, and that Istio is not using the software project. They are simply using kind of the specifications that we've set forth as part of the SPIFFE set. Okay, so back to this registration API here. This is kind of a mock set of selectors that would be registered when running on top of Kubernetes. And these selectors will say, within this particular namespace, this particular service account, also running with this Unix UID 1001. We know this to be the signature of SPIFFE ID foo/bar, and when we can validate that this is the caller, issue it a certificate with this SPIFFE ID. So this is just a quick diagram of that node attestation that I mentioned earlier. So when the node comes up, it calls this plugin called the key manager, which can be a memory or it can be backed by hardware like TPM crypto hardware. And also calls this a tester plugin. In this case, you have AWS showing there. And then calls up the node API on the control plane, which calls its own node attester, which has matched but different logic that understands how to call provider-specific APIs in order to validate the information that's been handed to it. A trusted third party, if you will. So this is a diagram of kind of what happens when a workload hits the workload API within the SPIRE project. So the workload API is not an authenticated endpoint. It is meant to be exposed locally only. And it is implied that the provider of the workload API is doing some sort of introspection in order to identify the caller. And this is done because at some point we have to do away with authentication and bootstrap things. This is where that occurs. So we have these things called workload testers. There's a misspelling on there, I apologize. And you can have many of them. So in the previous example where I gave Kubernetes specific with selectors and Unix specific selectors, we would have a workload tester plugin for each to handle each one of those things. And when the workload hits this endpoint, we pass metadata about the caller to each one of these plugins, and the plugin then takes that metadata and introspects the caller in order to derive the set of selectors, which is returned to node agent. And at that time, we use that to kind of match up, okay, who is the caller and what SVIDs are they permitted to fetch, and they'll be issued at that time. So getting a little bit more specific about what this looks like under like a Kubernetes deployment. In terms of registration, there's been a few. So to be clear here, we don't really have this hammered down just yet. We're trying to kind of work through what this would look like. But right now we've got a few options in terms of like how we get registrations done. One of them is to have a sort of adapter, which sets a watch on the API server, and then would run externally to the SPIRE project and Kubernetes, or on top of Kubernetes perhaps, and receive updates from API server. And as those updates come in, we'll massage in whatever way needs to be massaged, and then post back to registration API. Some concerns have been raised with this approach in terms of race conditions. How long will it be till the watcher is notified, and will the registration happen before the container starts? So another option there that was kind of thrown around was using an admission controller, which calls back the registration API as soon as a workload is scheduled. The obvious downside of that being a very tight coupling between the SPIRE system and Kubernetes scheduler. And the third option is that has been kind of thrown around as a kubelet plugin, which would since a single owned node would be able to modify the registration entries.
So this is registration that is trying to say this pod is running on that node. This is not registration for trying to say this node exists. Correct.
This pod is running on this node. Here are its properties, and this is the SPIFFE ID it should be given.
Okay.
So in terms of node attestation, which I think is what your question just was, how do we know, how do we bring the node into the SPIRE trust domain, if you will? There are kind of two largest options that have been floated. One is just completely SPIRE-based, which is leaning on that native SPIRE platform attestation and pluggable infrastructure, which may or may not be aware of the compute platform that you're running on. And we have a join token option there as well, which is fully SPIRE native. This of course would be kind of divorced from Kubernetes identity as it stands today, but could potentially be used to bootstrap new Kubernetes clusters because we can do really strong platform specific attestation of new hosts. The second is fully Kubernetes-based node attestation, where we give the node attester plugin a Kubernetes API token, which it uses to hit the API server and generate a certificate for itself. And once the certificate is successfully issued, it uses the certificate to perform the node attestation against the SPIRE control plane. The advantages here is that it's easier brownfield deployment on top of Kubernetes. You don't have to configure any of the platform-specific stuff, and you don't have to, but you do have to still give it, these somehow seed it with these API tokens. And then as far as the workload attestation goes, so this is when a workload hits the workload API, how do we validate the caller is who they say they are, or how do we even know which SPIFFE IDs to issue? I think there's not too much contention on this front. There's a variety of options available. We can hit kubelet API, we can introspect Docker engine directly, we can call out to Kubernetes API server, and we can also introspect the Linux kernel for C group information and things like this. So I think that in terms of workload testers, we have a lot of options, and there's pretty rich system there. Does somebody have a question?
I was just going to say that not all of these work for everyone, right? So Docker engine, there's been a lot of work on cryo, so I wouldn't want to rely on Docker. The kubelet API isn't very well defined overall, right? It's an organically grown API server. And then for the Linux kernel, how would you deal with containers running on Azure, right?
Sure. Containers running on Azure, you're talking about like their container runtime, or you're talking about like...
So from a pod perspective, right? It looks like a pod. It wants to run something in it, but it's still going to want a way to get its own identity. And I don't know how any of the solutions so far, I don't know if it's come up at the container identity call yet. But
yeah,
we're there.
To be quite honest, I'm not sure either on the Azure case. I guess the point I'm trying to make is that I think they're, like, because this is pluggable, you can write any kind of logic to do this attestation and jam it in there. And what you're required to use is mandated by the selectors that you choose to use. So the selector, the types of the selectors are actually typed. And the type of selectors that you register on against the registration API dictate which plugins must be used in order to generate that attestation.
Okay, that makes sense.
So if some things work for some folks and not others, I think that that's a case we can handle. It just means that we need to kind of tweak the different types of selectors we use during registration.
Okay.
This also seems like a good use for some of the stuff that the container identity working group is talking about, because that would give your SPIRE the ability to authenticate a very specific request from a container.
Totally, yeah. I mean, that's exactly what we're looking to do. So yeah, I'm excited to see how attend the next meeting. There's good work going on there. And so finally, I'm kind of nearing the end here, wrapping up. The last kind of thing here is just, SPIFFE in Kubernetes. So we just kind of went over what SPIRE looks like on top of or underneath or next to Kubernetes, and what integration points would be required and how those look. But I do kind of just want to make a mention here. I'm totally aware that there are some automated signing semantics within Kubernetes already. And so there might be some hesitation and wholesale swapping that or ditching the work or whatever. So I just kind of also wanted to point out that, and as kind of Mike pointed out earlier, Istio runs in this fashion where, you don't necessarily have to take the project. But we do think that adopting these standards, these SPID standards, and how to encode the identity into a certificate, how to validate that identity, we do think that adoption of those standards is really, really valuable. So even for folks who are not necessarily wanting to pick up SPIRE and use it as it is, or for whatever reasons they have, we do hope to kind of see folks using SPIFFE compatible certificates or SPIDs and their own CA mechanisms in the future. And that's all I got for you guys. There's the link to the GitHub repo. Happy to answer any questions you guys have. But this was just kind of meant as a high-level introductory of kind of what we've been working on and the direction we're going with regards to Kubernetes.
Thanks. That was really interesting. When you get further along, I think I'd be interested in seeing the integration of this with the container identity, as for instance, in a full demo with a pod.
Totally. Yeah, and we're working quickly towards kind of the v0.1 release of SPIRE. We do have, if anyone's interested on the call, we do have a Kubernetes specific SIG within the SPIFFE ecosystem. I think they meet twice a week or once every 2 weeks. I think
every Friday, Evan. Every Friday. Right now, every Friday, but we will increase or decrease the pace depending on the.
Yeah, Vipin is actually the one leading that SIG, and so the information on joining that SIG is available on the GitHub repo. All the community information is there. So if you're interested in participating or even just following along on our work, and particularly the Kubernetes specific stuff, feel free to join those calls.
Thanks.
Yeah, I'd also just give a plug for the a lot of the stuff you were talking about, like injecting things in the containers and how that can be done at initialization time, or like in response to a watch, or done on the node. A lot of those are being discussed in the container worker call, and how that could be done with like initializers or external admission, and then pairing that with like volume plugins or flex plugins, things like that on the node. So if you're interested, a lot of that is being discussed.
Yeah, that's really good to know. That's definitely on our radar and something that we're trying to figure out too. So, we're happy to kind of lend a hand and also, give our input and then hear what you guys think is the best approach there. We're not the experts. We're just trying to make it work in a fashion that gets like 90% there.
Great. Thanks for the demo.
Thank you very much, guys, for listening.
All right, so if we can get the agenda reprojected, we'll go ahead and move on to polls of note. First one is the Bootstrap token with extra groups. I think I saw that LGTM this morning. It was something from Matt, as I recall, letting you just specify the groups that you needed. Client cert rotation to beta is another one. I've seen that one in passing. That's yours, Eric, right, Eric?
No, that's Jacob's.
Jacob's. And you know, that one will be good. I haven't been following that one as closely. And then configure OIDC value prefixes. This is the one to get rid of that really nasty name, right? For users.
Yeah. Yeah. So if you use OIDC, please do go look at that. The idea is that right now we conditionally prefix your username based off of if you're using specific claims and don't prefix groups. So to make the OIDC plugin a little bit more useful, we're hopefully going to let you specify those prefixes manually, or specify not prefixing it if you so choose.
Yeah, I remember, and there was concern about collision when you had multiples, so that was why it was there to begin with. So yes, if it's important to you, it's definitely worth looking at.
Yeah, both collision and trust of the provider. So by default, we prefix with the provider, but if you fully trust the provider and you know that they tightly control usernames and aren't going to collide with something that you're concerned with, then you can choose to opt out of the prefix.
Then moving on to the designs, reduce the scope of the node on the node object. I think I remember this one. I'm associating it with either CJ or Mike. This wasn't Google, right?
Mike opened up this one last week. You want to call Mike?
Yeah, I'm around.
Read a summary.
So I capture a conversation that I had with CJ and Robert Bailey. Essentially, an issue that we have graduating. One of the blockers of graduating server certificate rotation for kubelets to beta is figuring out how to secure the addresses reported in the node status of the kubelet. We want to use those to validate the serving certificate signing request. And right now they're currently self-reported. This gives us this allows an attack if this feature is enabled, where somebody can get serving certificates for basically any name signed by the root CA, as long as they have control over a node. So there's a trade-off here. If we move rotation to beta without locking down this attribute. Another example of the attributes are attributes that we want some strong exclusion, like taints and labels of nodes. So I propose in the proposal to move these to setting these fields to a centralized controller, probably potentially the cloud controller manager, using a node initializer and also a reconciler for the node objects, and just prevent nodes from setting those fields.
Yeah, the tricky bit was dealing with version skewed kubelets that already exist and are trying to report these things, like whether we reject them or strip the labels and taints and addresses.
Right.
What we do, like for the next 2 or 3 releases, until we get them to stop trying to set those fields on themselves.
Yeah, that's a good point. I think that it would be okay to just throw a blanket out in node restriction admission controller. Does that sound reasonable? Is that semantic breaking change?
So in the documentation for that, we explicitly say we will continue to tighten and modify these in future releases. So I think as long as we are cognizant of the effect this is having on version skewed kubelets, we are within we are within our rights to continue to modify what it does. It's an intent-based admission plugin, and so I think we have to be concerned about that version skew, which is why the thought about dropping the data rather than rejecting, so
Right.
that a kubelet could continue to register itself, and a current version controller could come and set those options on it. Because our version skew says the controllers have to be at the same level as the API servers.
And kubelets are n-2, as I recall, right?
That's right.
That all makes sense to me.
Okay. One thing that this intersects nicely with is actually work that's going on in like the cloud provider space to enable external cloud providers. So one of the interesting things that this means we would have to do is a kubelet would register itself basically just a shell of an empty node object. So it would only have to know its own name. And then it would watch that object to determine what addresses it should ask for a serving cert for. So this actually reverses the data flow, which is basically what you want with an external cloud provider. You don't want every kubelet to have to know how to interrogate the cloud provider. It should be told. So it's interesting. It means we'd have to tease apart the kubelet bring up to multiple phases. Like first register yourself, then watch for your addresses, then ask for a serving cert, and then go into a loop to say if your addresses change, you need to go ask for a new cert.
Right.
So there's work there as well.
Yeah, those are all good points. I will add a section on some of those things in the doc.
I think there's value in the node restriction admission plugin. And this is actually something I was working on and trying to get in this release. And it's looking like it might not happen this release, but there's value to having sort of standard labels and taints that are not used to partition along security boundaries. So the ones that come to mind are the 3 labels that all nodes add. So like OS architecture and what's the other one? Maybe host name?
Instance type.
Host name is questionable. Instance type. Having a set of labels and taints for things like out of disk, out of memory, that we say it's reasonable to let nodes set these labels and set and unset these taints. And then everything else we're going to drop. And then have a way in the admission plugin, if you really, really don't want them to set anything, you can tell us to not even allow those. But I think it's useful to allow the basic set. I don't know. Thoughts on that?
Yeah, that makes sense to me to have a whitelist that we extend for benign stuff. I'm curious about would we expose a whitelist to users as configuration, or would we just use a whitelist for our own purposes?
The way I had structured it in the poll I was working on was Boolean that says include the standard ones or allow the standard ones, so they could turn that off if they wanted, and then a whitelist that they could separately specify. So if someone was happy with the standard ones and they wanted to allow like a few others, they could.
Right.
If we're moving to an initializer, that user specified whitelist might not be necessary. So
yeah.
I would like to do less in config and more via the API if possible.
And what do you think about people running without cloud providers?
Yeah, that's tricky. We have to consider it. I guess the options, people running without cloud providers are starting up their kubelets with these command line options to say, set these labels on yourself. And so that's probably where the whitelist comes in, to be able to say, yeah, allow these labels to be set. And what they should not do is tell nodes to set labels on themselves that they are intending to use for security segmentation purposes. So if you want different node pools and you say you guys are super secret nodes, and you guys are all my government workloads, and you guys are all my competitors' workloads. And if they're using labels for that purpose, the nodes shouldn't be the ones setting those in the first place.
Right.
So the whitelist should allow things that are benign as far as their topology is concerned.
Yeah, the whitelist is reasonable for that use case. What about addresses on deployments without cloud providers?
So without a cloud provider, you don't have a central registry of addresses. So, I mean, if someone wants to implement their own central registry of addresses, that really starts to sound like an external cloud provider.
Right.
And so I would kind of push them to the external cloud provider case and say,
that's
you're responsible for
config
running a controller.
management too. Yeah, I mean, that's called config management, and everyone has it. And if they don't have it, they would get it.
Well, but I mean, it's a question of who do we trust in that scenario? Like if you want to manage your addresses centrally, then you are running an external cloud provider. You may not know it, but you are.
Right.
So that's what I would push them to.
Okay. That all sounds reasonable. I'll try to update the doc.
There was one other thing that I was thinking about when looking at your proposal. I'm trying to remember. It just slipped out of my mind. Go ahead. Maybe it'll come back to me.
I could also see like a manual node, that middle bootstrapping process. If we made that easier for the no cloud provider, like this node registered, waiting for you to fill it in. You're the admin. Plug in the info you need.
Oh, I remember. Deletion of nodes while tainted. So this is like the things that we can't let a node do because it could compromise other nodes. We can't let it attest to its own addresses because it could get a cert valid for other nodes' addresses. We can't let it label itself because it could steer workloads to itself. We can't let it untaint itself because that would also let it steer workloads to itself. And deleting itself while it's tainted is like a special case of removing a taint. And so I think that's like the one weird edge case that I thought of. So we probably wouldn't let it delete itself while tainted.
Can you describe what attack that would prevent?
So I'm a node. I have a node credential that lets me register myself, and that's it. And I get compromised, and so the administrator taints my node, which prevents any pods from going to my node, and now is working to like bring me down. I should not be able to delete my node object and recreate it.
Okay. All right, I'll add that to the list of things to discuss on the doc.
Should a node ever be able to delete itself?
We had a long conversation about this about a year ago. The only reason it does today that I'm aware of, the only reason it tries to today is during bring up, if a node API object exists that has a different external ID, the node will try to delete the object so that it can recreate it with the quote unquote correct external ID. I think that's a weird case. But we definitely ran into it, right? If you bring up, shut down and bring up a machine in a cloud and it obtains a new IP address or a new external ID, it's gonna try to re-register itself and fail because that field is immutable in the API. So it deletes and recreates. That's the only case I know of where it tries to. I'd be happy if that use case went away.
Yeah, I'll have to think about that.
So. But I don't think preventing deletion while tainted is going to be especially concerning for that use case. That's not a, yeah, that condition is not one that was really addressing.
Thanks for the feedback.
Yep.
All right, so the other one that I am aware of is the Vault KMS provider. The proposal is open. This one is about basically being able to encrypt your secrets at rest and use Vault to get them back. There are a lot of details in the design. It would be very nice to have a second one. There's one in progress now for GCE. I remember that going in, or at least being reviewed and targeted at 1.8. I read the design at a high level. It seems to make sense. For Vault, I didn't go into excruciating detail. But if you're interested in trying to use Vault to encrypt and decrypt your secrets, not actually as the secret accessor, but to store a key, then this is going to be worth you reviewing. And it'll be good if someone who is familiar with Vault came in and went through and made sure it was all tractable here.
Clayton or Greg, are you guys on the call? Someone who was involved in the encryption stuff would be good to take a
Yeah,
look
I need
at
to
it.
look at it. It's currently pretty far down my list, unfortunately. Greg, I don't know if you have anybody.
Greg's not on the call, but he's sitting right next to me.
Yeah, this is okay. I wrote that PR for the Vault KMS provider. Any feedback, any input you guys have would be nice. It's been out there for a couple of weeks. I know people are busy. We've got some code ready. We should be starting the code PRs later this week as well. It would be nice to get this into 1.8 if you've got time for it.
You said nice to get into 1.9, I assume? I didn't hear clearly.
It would be nice to get it into 1.8 if people have the time to review it and provide us comments.
I'm going to say that I think 1.8 is going to be closed for the actual feature, but for targeting the design review, that probably makes sense.
Sure.
And you should ask in the SIG Auth channel. I know there have been a couple people asking about Vault integration, and I imagine this would be very interesting to them.
I'll socialize it there. I'll push it out there and see if people have comments there too.
Okay. Then the self-subject rules review. I've seen the poll. I was happy with the API. It looked very similar to what we had in OpenShift. I guess, Eric, you're asking about putting it in V1 as opposed to putting it into a beta version?
Yeah, so the basic, this wasn't actually raised on any of the either the proposal or the PR, but the sort of question is that I'd like to ask here is, how do we plan to introduce an API like this if it should be in the authorization API, which is in V1? Is the fact that it's been working in OpenShift enough of an argument for us to do that? Do we just introduce it into the old beta one first? Does it need to be in its own unique API group? I would appreciate any feedback on that side, because I'm not sure I can make a confident decision.
Right. So in terms of a separate API group, on the API machinery side, no, it belongs in the API group it's in. If we were not confident in the API, we would start it at one of the prior levels, and you would only put it into the version that it belongs at. So if it were going to be a beta API, it would go into the beta API level that you have, and you would not reuse a version. So if V1 beta 1 had already been created and then retired, you would create V1 beta 2. For this particular API, I have a very high degree of confidence in it. Jordan, what about you?
I'm just given the expression of the expression of the rules is modeled after RBAC, and that's had extensive exercise. The way you query, I think, has been refined and kind of built on the experience we've had with this API in OpenShift over the last year and a half. The fact that this is not a persisted API is nice. You submit a review and you get back a review object, so we don't ever have to deal with data migration for this API, which is really nice. The main difference between this API and the existing one that we've been using in OpenShift is the ability to indicate partial results. And so I'd want to think carefully about that. If you have multiple authorizers and only some of them support enumerating your permissions, you can get back an answer that says, here are the permissions we know about, but these results may not include all the permissions you have from all authorizers. And so
that's also something I'm concerned with.
That I want to think carefully about how we represent that. That would be the only hesitation about the API.
Awesome. Yeah, I think it's just a high-level feedback was good before I CC'd the API reviewers or not. So thanks. Just to address the actual what happens when you get a result that is not complete, the error code in the actual status is supposed to, not the error code, the actual error field is supposed to indicate that, but you could probably do that better. Yeah.
All right, well, I think this one is pretty urgent to determine what we're going to do with it. So we should continue to talk about it and reach a resolution probably this week, given freeze.
Yep.
I agree.
All right.
Just to go back, one item. I'm now on the call. Hi, it's Greg.
Hey, Greg.
So
we've moved on.
I did read the Vault KMS design. I had one question about different authentication backends. So I know there was mention of the cert backend, and that was kind of the only thing that I was kind of wondering about. Would there be, if people want to use different authentication backends? I think there was 2 or 3 mentioned maybe in there, but it wasn't sure. It wasn't clear to me how you would plug in the rest of them. Would we need Kubernetes changes if you wanted to use something different? How that would work?
Hey, Greg, this is KK. Thanks for the feedback.
Yeah, no problem.
I think your question was if I wanted to use a different auth backend that I picked from whatever Vault supports,
yeah,
do I need Kubernetes changes or not? That was your question, right?
Yeah, and I guess would it just be config format changes? I guess if that is the case, then maybe you need code changes as well.
The list of auth backends that we're testing with right now is what's in that PR out there.
And yeah, you were doing otherwise, I think the right thing. So that was the one kind of minor thing that I had a question about, but I'll take another look at it too.
Sure.
Greg, while you bring up the sections PR, I also put that in the PRs of note. If you want to look at that, I think there were a couple of final questions about where that was going and how it was registering itself. So if you want to take a look, that'd be really helpful.
Yeah. Okay. I'll do that too.
All right. Well, I think that all timed out really well. We'll go ahead and close the call here, and I will talk to all you guys later.
Awesome.
Thank you, guys.
Thanks, everyone.